Welcome to the Perranporth Fieldwork video for 2019 exam students only. If your terminal exams are in 2020 or later, you will not be doing this case study. This video is going to be the overall video. It will be all the different parts stuck together. What I'll also do is I'll split the different parts into part 1, 2, 3, 4, 5 and 6, and they'll be on the playlist as well, so you can either watch it all the way through using this video, or alternatively do it bit by bit using the separate videos. Don't worry about the joke, it is coming. I'll explain what we're going to do in the next slide. So with this video, what I've decided to do, it's going to be quite a long one. Up on the board is the 6 different elements of the geography spec, if you like, that the exam board want you to know. So you've got their suitable questions, selecting, measuring, recording data, etc. This video will cover absolutely everything you need to know for the Perranporth field work. Now, I thought that on its own would be enough to make students watch it before paper 3. However, if that's not the case, every time you see this slide, I will go through what you have covered so far and tick it off with a red box. And every time this comes up, you will get a little joke to try and keep you watching it, because a free education and free service isn't enough, is it? So our first joke is, what did the daddy buffalo say to his son when he left home? Bison. Like bison. Bison. Anyway. The title for your physical fieldwork is Are Coastal Management Strategies Successful at Perranporth? This video will cover everything you need to know that could possibly come up in the paper 3, very important, paper 3 exam for geography. Okay, and so what makes a suitable inquiry question? You guys, this year, you got 2 inquiry questions, one physical, one human, and I'll put that up on the board in a moment exactly what those are. But to make a successful inquiry, you need to be smart. Now, what this is one of those like acronym things where every letter means something. So in terms of the S first, your inquiry question, your title needs to be simple. It should be a single question, like a simple hypothesis, and make sure it has a clear link to geographical theory. I'll come back to that in a moment, but both of your titles do achieve that, but they need to be nice and simple, nice and straightforward. The M there is measurable. Can your inquiry actually be measured? Is it possible to get adequate data? Can you actually measure something that will give you an answer? In terms of the A, A is achievable. Is the location easy to access, for example? Can it actually be done in the amount of time set? Can you even visit the location that you're trying to do an inquiry question in? For us, doing an inquiry question in Barbados, for example, it just simply isn't going to work. The R is realistic. Can your title actually be achieved? Will it be possible to reach a viable conclusion? Can you actually get to a point where you can clearly say yes or no? Timed. The T I should say is timed. Does your title require data over a long period of time? If so, a one-day fieldwork is not going to work. So those SMART targets again: simple, measurable, achievable, realistic, and time. So what about your titles? Green being physical, red being human. Reality here, particularly with the green physical title, there is an argument to say that isn't really achievable. In one day's worth of fieldwork, you can't possibly ascertain whether the coastal management strategies are successful. For numerous reasons. 1, you've only got one weather condition to look at. 2, you can't ask all the residents of Perranporth in the 2.5 hours you were there. So is it an achievable, realistic title? You can certainly argue not. But the concept being that as an overall, these 2 titles are good enough for your GCSE inquiry. Okay, and after considering whether you have generated a suitable question for geographical inquiry, what we now need to make sure you're aware of is the theory, or the concept, if you like, that's underpinning this inquiry. Tied up on the board again, Are Coastal Management Strategies Successful at Perranporth? So then, the underpinning here is that you guys need to know that the coastline is dynamic. It is constantly changing. Coastal processes, in this case, were most interesting hydraulic action and abrasion, but also flooding as well, I suppose, can cause this change. Coastal management is aimed to protect the value, socially, economically and environmentally, and to reduce the vulnerability to these processes. And our big question is to work out whether that management is successful. So let's put it in a slightly wider context. Perranporth is both an economically and socially valuable area. The best fact to prove that, remember, £100 million worth of value of buildings behind the seawall in Perranporth, and this includes some businesses like the Watering Hole and the Dolphin Cafe, as well as all those houses in there as well. Don't forget it, Perranporth also has environmental value. Rare species like the sand lizard and marram grass to a lesser extent are found within the sand dunes. However, Perranporth has proven vulnerable to physical processes in the past, including flooding and erosion, especially in 2015 when the car park was flooded and cars were damaged. Your fieldwork question, therefore, is to work out if the management at Perranporth are effective in protecting that value from the activities of the activity of humans, but also your physical processes as well. So we'll consider the physical process first. We've already mentioned hydraulic action, abrasion, as well as flooding over the sea wall, and also the future rising sea level potentially causing issues as well. So that the sort of managements for your physical threats are hard engineering, whereas your human threats, those made by tourists generally, like trampling the marram grass or litters and fires in the sand dunes, those are generally managed by softer engineering, for example, paths and signs, as opposed to the more hard engineering for the physical threats. So that's the general underpinning. You need that underpinning to be able to understand and answer the question. Okay, then one of the questions in the exam that could come up from this part of the course, part of the spec, is to justify why your location was suitable. Now then, green, obviously your physical fieldwork. Pink or red, that should be, is your human fieldwork. The first two boxes you can see are exactly the same. If this is a 2-mark question, you go your point and your so what. It's close to school, so you save money on transport, 2 marks. It's close to school, only a 1-hour coach journey, so save money on transport. If they're the same point, as is the second point there, you get there quickly, you've got more time to collect primary data on the day. The final one is actually the same as well. You might see that several sites can be accessed easily, all sites are contained, so safer. Talk about Plymouth CBD here, there are only 6 sites and they're all in a rectangle in the CBD, which are all walkable. The reason we take you there is it's safer than perhaps going to Truro, more of a zigzaggy medieval layout really, and as a result of that it's much more difficult to keep a track on the students and therefore you're less safe. Okay then, risk and controls, last bit of this video. For the physical fieldwork first, every specimen assessment exam has had one of these questions, how do you reduce the risk? So it's fairly likely another one's going to come up. With that in mind, we've got our risk there and you'll be asked how you can reduce those risks. Always be specific on this question. Stay 10 metres away from the cliff face is a specific. Carrying a first aid kit and emergency phone number is a specific. You don't obviously have to write the mobile phone number down, that would be ridiculous, but the idea is that those are specific to the threats involved, jellyfish stings as an example. I'll leave those up on the board for just 5 more seconds. The idea is, if you get that sort of question, you'll clearly identify risk and you then simply explain how that risk is reduced. It really is a straightforward, easy question. So at this point, we'll just draw you back to the specification. This part of the video so far has covered everything you'd need to know in box number 1, linked to your physical geography title, Are Coastal Management Strategies Successful at Perranporth? So well done, you've got through this far. Your reward, a joke, which will be, I don't know, what you get if you cross a hyena with gravy. A laughing stock. Video about to move on. We'll look at the second section now, which is essentially the methods you did on the day. So really crucial here, you know the difference between primary and secondary data. Primary is data you collect yourself firsthand. It's not manipulated anyway, you're simply counting or asking questions, you just simply record what's given to you. Primary data because you went out and got it firsthand. Secondary data, information from other sources, it's been collected by someone else, it's been manipulated by someone else. We have to remember here that the issue straight away becomes this concept of bias, and remember also that secondary data can be out of date. Okay then, so what primary data did you collect in your physical fieldwork at Perranporth? So we'll start with the top one. You collected wave count and wave height data. The count you did on the day, the height you would have worked back out in the classroom using the wave height formula. The reason why you did that is it provides evidence of physical processes. So if you have higher waves in certain places along Perranporth Beach, that will therefore mean there's more force crashing onto the cliffs or sand dunes, and therefore more hydraulic action or more ability to abrade with heavier load within the sea. So therefore there's more chance of undercutting or slumping, or alternatively more chance of flooding, more chance of erosion happening. So the concept there is the reason why you've collected that data is to try and prove the physical processes that are occurring. The final two you might notice are in red, they're in a different colour. The reason for that is they're actually useful bits of data that you're collecting, as opposed to the wave count, which we'll see later probably isn't that useful. When we look at the next one, bipolar survey of defences, the bipolar survey looks something like this, just as a little reminder. Apologies, it's very, what's the word for that, where it's unfocused, however you'd want to put it. But it scores between -3 and +3 with the different categories. So, for example, in poor state of repair or in a very good state of repair would be either -3 or +3. So the reason you did that, you had to consider if the defences appeared to be working well or not. Did they show signs of wear, for example? And also to compare the different defences to see if some defences are working more successfully than others. The final bit of data you collected, and you definitely did this, is you did a questionnaire of local residents to consider those people's opinion. The most important, or the biggest justification for this, is the fact that you had to do this to get data over a longer period of time. You only visited Perranporth for one day. What you needed to have done is to have got the information for people over a much longer period of time to therefore be able to conclude, rather than just on the single day, to be able to conclude on the last 20, 30 years of how successful these defences have been. So it's a greater temporal range, temporal regarding time of evidence. Those are the three bits of data that you collected on the day. Let's have a little look at sampling. Right, sampling, really, really important. In terms of all geography fieldwork you'll ever do, to be honest, you will not be able to record every possible bit of data. You will have to sample. A sample is the idea where you take a small section, or as large section as possible really, of the overall area, and then you consider that would be repeated in other areas that you didn't survey. So if you look at the number 1 and number 2 diagram down the bottom, if you do one of those X's, the idea is if you do the X there, it will be repeated in the rest of that blue circle. So, I mean, the reason for that is we simply didn't have enough time and didn't have enough money to do all of the surveys properly. But the big idea is you guys need to be aware that we did sample in both of your field works. A nice little explanation there in the text is, for example, if you're doing a pebble count, I know you didn't do one, but if you were doing a pebble count, there's no way you're going to count every single pebble on Perranporth Beach. You would only survey, let's say, 10, and then assume that the results are the same throughout the rest of the beach. So first things first with sampling, sample size really important. The larger the sample size, the more accurate the data. So if you're looking at number 1 down at the bottom, you've taken one sample site in all of that area. Clearly, investigation number 2 is far more accurate on the basis it has a larger sample size, more sites, therefore it's more accurate. So number 2, more accurate. Big problem here. Number 2 will also be much more expensive and take a lot more time. Okay, then there are a variety of different methods of sampling that you'll need to know, stratified, systematic and random. On the day in Perranporth, you actually did 2 different types of sampling. Firstly, you did stratified sampling, which is where you choose specific areas on Perranporth Beach which have the types of management that you want to look at. So you did a site at the sea wall, you did a site at the Gabions, you did a site within the sand dunes to show all the different types of management. So you chose specific areas to survey each type of management. That is stratified sampling. You also did systematic sampling, where you chose equally spaced areas of the beach. It might have been 10 paces apart, it might have been 10 metres apart, it might have been 100 metres apart, and you measured how high the waves were across the beach to see if there was any difference in the height. So that's systematic because you are laying down a 10 metre distance between measuring the height of waves. So on your day you did stratified sampling for each of the managements, but you did systematic sampling for the height of the waves. However, there were some other methods of sampling that could and possibly should have been used on the day. Regarding your questionnaire, you didn't have any sampling in place, and what that meant is, of the 34 people asked, generally only 2 age groups have really been asked. It's those over the age of 65 and those under the age of 18, on the grounds that they were the people you were comfortable to speak to. As a result of that, our evidence within the questionnaire data is currently too biased towards those people. What you should have done really is to brought in the systematic sampling, or actually a random sampling, to make sure you remove that bias. So for a systematic sampling, what you would do is every 5th person who walked by, you'd count 1, 2, 3, 4, and then that 5th person, whoever they were, it didn't matter, you would ask that person. And as a result of that, it takes away any bias of you only asking people you feel comfortable to ask. The other way of doing this is random sampling, which is use a random number generator to pick the numbers. If you've got a very clever calculator, it can do this, and you would say, okay, then random number generator between 0 and 10, and it would go and give you the number 7, and therefore you'd wait for 7 people to pass you, and then you'd ask that person. You'd then go back to the calculator, hit the button again, 2, and you'd count 1 and 2, and you'd ask the next person. It completely removes any bias from your questionnaire. You didn't use those sampling methods, but it is certainly a criticism of your physical fieldwork day that you didn't. Okay, then that's everything from box 1 and box 2 now completed. So obviously a joke on its way to reward you for revising or something. What should we go for? What are the biggest types of ant? An elephant. Yeah, good one. Right then, part 3, let's move on. We need to look at how did I present my data. You had 3 methods used on the day, which were wave count, questionnaire, and the bipolar survey. So how did we go about presenting that data? So the first method you used to present data was a located bar graph, and you use this for the wave height. So a located bar graph, firstly, is a way of comparing quantities or frequencies in a single category, but crucially you actually apply them to the location. If you look to the right hand side there, you've got one about elephant populations in southern Africa. Obviously you didn't do your field work in southern Africa, but what you would have done is you'd have taken the wave height data you collected and plotted that onto the beach and headland at Perranporth. So the positives are it's very easy to identify the trend. In your results, actually, higher waves were nearer to the exposed headland. However, the negative is as soon as you put bars onto a map, they will actually cover the coastline itself. So it covers up named examples. It might actually cover up the crucial part of explanation, because you have those almost blocks of colour that will block certain areas of the map. It's also not the easiest to read either. I mean, if you use the example there on the right hand side, the scale is out to the left in elephants in tens of thousands, or in thousands I should say, and you then have to measure the bar and drag that across to the scale. So actually it is a little bit tricky to get the specific figures as well. You also used pie charts. Pie charts were used for the questionnaire data, which was divided into percentages when you got back into the classroom. Pie chart, simple circle divided into segments, percentage figures written on to help interpret the diagram above. That's just one that shows employment types in each given country. The ones that you did is you took certain questions, like for example, have you heard of a seawall? And if 100% of people, or 97% of people said yes, they have heard of that, you colour in 97% of the circle. Really, really straightforward. It is nice and easy to see the overall trend with a pie chart. That's the reason we did it. However, it is harder to compare the size of segments, particularly if the figures are not added to the pie chart. Final graph that you did on the day was a radar chart, also called a radar graph. A way of displaying data with a single scoring system. So in terms of your bipolar surveys you did, you had a score between +3 and -3 in all categories. It means that you can apply that to a radar chart. If you had scores between, I don't know, 0 and 10 for one category and then very good to very poor in another category, you couldn't use a radar chart. You can only do it where there is the same score in place for all different elements. Positives here, it is really, really easy to identify anomalies within your scores. If you look at the example shown on the board there at the moment, you could look at that and follow the blue line across, and the points that stick out really far, like December, like June, really, really stand out to the person, so it makes the anomalies easier. It also, the general trend's nice and easy to see, that the larger the radar, the better the score. However, it can be quite difficult to actually calculate a total score as well, because you have to add up each individual part. It is tricky to read a radar graph when you've got several points overlapping each other, as you have in the reds and blues there. Like, look at April as an example. And also, in terms of colourblind people, it would be very, very difficult potentially to use this type of graph. However, in the example on the board, you can see they've used different shapes to make that a bit easier. So in terms of this field work, in terms of the graphs, you had located bar graphs, pie charts and radar charts drawn. You will need to know the advantages, disadvantages of each of those methods of displaying data. Now, a little extra one you did on the day was a field sketch. A very effective way of recording observations made in the field, a quick little sketch, and then you can annotate regarding whatever aspect of geography it was you were looking at. The positive, obviously, you can be used in the classroom. It's that like a remembering tool, because some of you went to Perranporth in year 10, in year 9 I should say, and didn't have any lessons till we came back in year 10, which really isn't ideal. The negative is, however, it's difficult drawing conditions when you were there. It could have been done in windy conditions, and it is very biased. When you're drawing a field sketch, you'll naturally enhance the fact that you want to, and as a result of that, you always have to take a field sketch with a little bit of a pinch of salt, whereas a photo is much more likely to be an accurate portrayal of what you see. A field sketch, the person can enhance whichever part of it they would like to make more clear to the reader. So those are the methods that you've used, those are the ways that you've presented data throughout the Perranporth fieldwork. You've got to this slide again, so you get rewarded with a little joke. I don't know. In the last one, it said, what ants are the biggest? I said elephants. However, what ants are even bigger than elephants? Giants. Right then, part 4. Part 4 is the describing analysing and explaining of fieldwork data. So what we're going to do is we're going to take the results in turn that you've got for each of the methods and have a little look at if we can make any links and give a basic description of the results that you've collected. So we'll start with wave height. The figures that you collected on the day suggested that there were 50% higher waves on the unprotected headlands, and that actually proves that wave refraction is occurring at Perranporth. However, if I'm being really honest, this evidence does not link to the title of success of management. It's a natural phenomena, wave refraction, so the fact that waves are bigger or taller or higher or steeper in any area of the beach is absolutely irrelevant when the question is, does the management work? So although there's something you found out on the day that you have 50% higher waves on the headland, the reality is it doesn't answer our question. Something that is a little bit more useful to answer your question is the questionnaire results. Questionnaire results I've popped up on the slide there on the left hand side. I'm sure you all remember doing this survey when you were there. You asked 34 people in total in Perranporth, and within class you lot calculated the percentage in class. Taking the ones that we're most interested in regarding your title of whether the management is successful or not. Question 4, 97% of people said they had been negatively affected by flooding. And question 6, 88% said they were either unhappy or very unhappy with the defences. So it doesn't point a very positive image of the Perranporth defences at this point. However, important for you guys to be aware of this in or for your conclusions in a moment. The final one is the bipolar survey, the one you would have presented as a radar graph. The general conclusion split into two here: hard engineering, the seawall, and soft engineering on the other side. The hard engineering scored poorly for view and evidence of damage, which was a -1 score. And that really does back up and support the questionnaire results, with people saying they weren't happy with the seawall. The soft engineering on the other hand, I should say, scored very highly, a +1 for view and for natural features, and that also supports the questionnaire results because few people were aware that the soft engineering was actually a management. That's exactly what you want from your soft engineering. You really want people to not even be aware there's a management in place, and it probably shows the management is doing its job if people are asked the question, are you happy with the management of the sand dunes? And they say, what management? Oh, the sand dunes are fine. They haven't even spotted that the management was in place. So back to this lovely slide again. You've now gone through and described our results quickly as a little reminder. We've looked at the ways you present your data, we've looked at the methods to collect the data, and we've looked at our suitable question for geographical inquiry. Another joke then, which ants are the smallest? Infants. Yeah, I like the ant jokes. Right, part 5 is reaching the conclusion, the shortest part of this video. Pretty much here is your conclusion. We'll do the hard engineering first. Hard engineering you probably deem unsuccessful in preventing damage from physical processes such as hydraulic action and flooding. The evidence for that is your questionnaire results, and your bipolar survey does not paint a pretty image of the sea wall. However, the fact that the town survives and that land use, remember that £100 million worth of value, continues behind the seawall, means that despite the bipolar and the questionnaire results, the seawall could actually be deemed successful on the grounds that land use has been maintained. An anomaly in the hard engineering is the gabions. Those are underneath the sand dunes at Perranporth. The issue with that is that it wasn't included in your survey because none of the residents actually knew they were there, and as a result of that, it's a tricky one because the problems with the sea wall, you could argue, would not be the case for the gabions. So a bit of an anomaly. You could argue that the gabions would be or have been more successful than the seawall. In terms of the soft engineering, it was deemed more successful by the residents and in the bipolar survey. As I've said previously, most of the residents were unaware that even was a management. As a result of this, you can probably deem it a success already, and then with the land use and the environmental value being protected, for example the sand lizards, you can therefore
claim or conclude that the soft engineering is actually rather successful at Perranporth. Soft engineering is more successful than the hard engineering. Okay, then 5/6 of the way through. Let's have a little joke to keep you going. Why do male ants swim better than female ants? Because they are buoyant. Buoyant. Part 6, final section, the evaluation, the big section. This is where you really, really need to be able to explain your point, use your so what rule, and develop your arguments of evaluation. Just before we get into this, just a reminder, evaluation means to weigh up and judge if you are asked that in the exam. So then, in terms of our data collection methods, what can we weigh up, what can we judge, were they successful? Well, just before we start that, you only went on one day in anti-cyclone or high pressure conditions, so the waves are very small, and as a result you can't really judge if the seawall's effective when there are barely any waves. So as a result, the day you went on means that the data that you've collected is not suitable for the task. Let's go into the individual methods then. We had a questionnaire. Questionnaire, I mean, as I've said previously, is incredibly biased. Your selection of people to ask was really biased. You only asked people who you felt comfortable asking, either the elderly or people who are around about your age, and as a result we haven't got the opinions of perhaps the people who actually own the houses and own the businesses within Perranporth. In addition, you only did 34 residents. There's 3,000 residents of Perranporth, so that's less than, around about 1% you've asked there. So clearly not enough to actually be considered reliable results, and therefore you could argue the conclusions could be invalid. Bipolar survey, again, it's only your opinion. You really should have taken an average there. That is a way to improve this survey. It is completely subjective, so it could well be inaccurate. The conclusions that 15, 14, 16-year-old students draw when looking at seawall may be inaccurate because you don't have as much geographical knowledge as perhaps the people who actually live there do, and as a result your conclusions could be argued to be invalid. The wave count, I just don't know where to start with that. I mean, it's not the landform count, I suppose, but the wave count is not linked to the overall title, so it's not linked to the conclusion, so it is absolutely useless data to have collected. As a result, are my conclusions accurate and reliable and therefore valid? Probably not. You have not collected enough data to be considered reliable. There were massive issues of subjectivity. The results are inaccurate. And as a result, you can't really build a valid conclusion. However, if I'm being really honest, if you went back to Perranporth again, the results would probably be repeated. So with that in mind, the conclusions are partially reliable, but you need more evidence to support your conclusion. I would argue the questionnaire results are more reliable than the bipolar survey because we're getting the opinion of people who actually live there and live with these defences, as opposed to students from St Austell. How can we improve this piece of work, Mr. Toms? Well, I mean, where do you start? You should really be going back and completing those surveys again. Particularly, it would be really a good idea to go into actually low pressure flood-like conditions to actually work out if the seawall works or not. Every seawall works in high pressure conditions because there aren't large waves. Go in low pressure conditions where the winds are rushing to fill that low pressure void and you'll have bigger waves as a result due to frictional drag. Then you could work out if a seawall actually works or not. You definitely want to return to ask the questionnaire to more people. You've got 34 people. You want a lot more people than that. However, one little problem was because it was so recent or so close to a flood event, which actually in itself could be argued to be an anomalous event anyway, you really should be going back about now, 4 or 5 years after the event, and saying, well, what do you think now? Because it's something so fresh in the memory may skew people's opinions. The bipolar survey, you should have taken an average to improve the validity. It's just your opinion. However, if you ask other people, it becomes more reliable data. It will probably take out some of the anomalous results. And really important, if you really wanted to see if Perranporth defences are successful, you should have compared the coastal defences with a similar site, e.g. Newquay, to see if a place with similar waves and similar rising sea level, if the management there is deemed successful or not. That would have significantly improved the validity of your results. And that's the works. That is everything you needed to know about the Perranporth case study or Perranporth field trip. Come and see us in HA if you are not too sure. We'll have one more ant joke just to finish this off. What do you get if you cross ants with ticks? All sorts of antics. Antics. Yeah.